Swagat and Sizu and P and Priyanka. Okay. Can everyone tell me about yourself? Like from where are you graduated? Which project you have done? And which subject you are comfortable in?
Who has to start first?
Just yeah. Start from the Swagat.
Hello sir, I'm Swagat Sahu. I'm from Brahmapur, Odisha. I'm a 2021 BTech graduate in Electronics and Communication Engineering. After that, I have undergone through a content training program, VLSI content training. I am working in science.
Where are you working?
Science India Private Limited.
Okay, Science India Private Limited. Okay, so what work are you doing there? This type of work.
So
what is your job profile now?
My job role is complete execution of FPG design for like specification capturing to onboard deboard.
Oh, okay. So, have you completed any project recently?
Yes, sir. Recently, I have worked on a project named as NAVCOM, that is a navigation and communication of a pilot trainer aircraft. So, basically, that project contains three major FPGs. So, out of three major FPGs, one FPG's functionality was to check the overall health status of that interfacing components. So,
actually, could you like your voice is not clear? Yeah, not speaking. So continue.
So my recent project was a NAVCOM unit. So NAVCOM is nothing but a navigation and communication of a pilot trainer aircraft. So that unit actually contains three major FPGs. One of the FPGs functionality is to check the overall health status of the interfacing component.
Okay, so are you planning to move some other domain, or what is your ultimate goal?
Ultimate goal is currently to work on this FPG domain only. After having certain level of experience, I will shift it to verification also.
Okay, you are planning to move to the verification domain. So you have completed any courses like System Verilog, UVM, Asserts and Coverage?
Yes, so System Verilog and UVM I have done. As I am not currently using UVM more frequently, so I need to brush up that thing.
Okay. Have you completed any like IP or side project which you have completed in Verilog or System Verilog?
Sir, can you please repeat?
Actually, you have completed any project in System Verilog or UVM or maybe
yes, Verilog? Many System Verilog related projects I have done, like small test benches for our designs. I have done from scratch and all.
Okay. So Sizu, can you tell me about yourself also?
So myself, Fiju NP. I'm from Calicut, Kerala. I have completed my diploma in 2019 from Government Polytechnic College, Cherakara, and BTech degree in 2000, passed out in 2022 from Rajiv Gandhi Institute of Technology, Kottayam.
Okay.
In addition with that, I have knowledge in digital, Verilog, System Verilog, and UVM also.
Okay, digital, Verilog, and System Verilog. Okay. Have you done STA, CDC, linting, and all?
No, sir. So, any software specific?
Okay. Hello, Priyanka.
Yes, sir.
Yeah. So, can you tell me about yourself? Like, from where are you and what are you doing currently, and which project you have completed, and along with the your favorite subject and related?
Yes.
Okay.
Yeah. Good evening, sir. I am Priyanka Labhade from Chandrapur, Maharashtra, PG Linux lecture. And in that, during the course duration, I have completed project on router project on design and router verification project on verification. Previously, sir, I have completed my MTech in 2017 from G.H. Rajani College of Engineering. I completed my HSC from Jalta Mahavidyalaya and HSC from Vidyaniketan. My hobbies are
Continue.
yes, sir. My hobbies are like playing badminton, listening music, like that.
Okay. So everyone know Verilog system, Verilog and UVM. So actually, I want to test your Verilog first. Okay. So I want to know about like start from Priyanka. Can you tell me like what is the blocking and non-blocking assignment?
The blocking assignment, we are using a combinational part generally, and non-blocking assignment we are using for sequential part of digital. Blocking assignment we are using to sign like equal to, and for non-blocking we are using less than equal to sign. For blocking assignment, they are continuous, depends on the previous value, but non-blocking assignment they are parallel. They are not depending on each other. Blocking assignment can cause a race around condition, but non-blocking assignment will never cause a race around condition. That's why it is more beneficial to use the sequential.
Okay. Do you know about the region of operation in blocking and non-blocking assignment?
What's it?
Region of operation in blocking and non-blocking assignment.
Actually, sir, I'm not able to understand the question.
Actually, there is a region of operation for blocking and non-blocking assignment.
Okay, in that active region, the event scheduling.
Event scheduling. So
sir, first is the active region. So in that, sir, active region first, right side of non-blocking is there, and for next is the NBA region. So in that, 1 second, sir. Sir, first is the active region in which right side of the non-blocking assignment is there, and next is the inactive region in which the 0 nanosecond blocking assignment we will take. Then next is the NBA region in which we take the right. Sorry, sir, I forget actually. I was revising DFT from yesterday. I forget.
Okay. So, are you targeting which profile you are targeting basically?
Actually, sir, first I completed verification, but UVM I'm finding difficult. So, Maven people told you can choose DFT. So, I was preparing for DFT. But then from last 3-4 months, I'm not getting.
In one go, you are not able to understand each and everything. You have to revise occasionally, and in system very long and UVM difficult. It's not an easy. If you try it, actually DFT, which which how like in DFT till now what you have covered?
Sir, you can ask any question. I will try.
Any question? Actually, I have so many questions. Maybe. Okay. So you have any specific software? Which software you have used?
Sir, in Maven Silicon, they provide test and tool, which is a mental graphics tool. In that tool only, we are doing all the programs. Like they provide the do file and they told how to run it, setup mode on analysis mode on inflation mode. So like that, we have to perform the task on test and tool.
Do you know about the round robin orbiter? Round robin orbiter.
No, sir, I don't know this.
Okay. Do you know about the FIFO?
Yes.
Okay. Just write the Verilog code for FIFO. Okay, and after that I will come to you. Take a pen and paper and write the Verilog code for FIFO. Okay. Hello, Swagat.
Yes.
Okay. Swagat, have you covered any protocol?
Yes, sir. SPI you got written, sir.
Okay. Tell me about the UART protocol, how it is work and what is baud rate you have used. Okay. Whatever you know, you just tell me.
Okay. UART is a asynchronous protocol, so it is a hand sector protocol. So
what is a hand shaking protocol?
Yes, sir.
Okay. And again.
Transmitter, it contains 2 ports only, transmitter and receiver. So generally there has to be one-on-one communication has to be there between transmitter and receiver, and maximum distance at which unit can able to communicate with each other is 10 meter at least at max. So as it is an asynchronous protocol, it uses a baud rate to transmit as well as receive the data. So in general, we are using 9,600 watts per second, but based on our speed requirement, we can vary that like 19,200 or 38,000 like that. So it basically it uses a data packet structure to transmit the data from one to another. So basically it contains a start bit, data 8-bit or 8-bit, then an optional parity bit, then a stop bit.
Okay. So, which bit is start and stop bit? You used like 0 for start bit or 1 for start bit? Which bit you have used for start and stop bit?
So when the transmission line pull down occurs in the transmission line, then receiver gets to know some data is being transmitted from the transmitter. After receival of data, again that transmission line again pulled back to high state. Then we get receiver gets to know that successful data transmission has happened.
Okay. So in the receiver side, we get the acknowledgement that this bit is 0 or this bit is 1. Like what? In only one, we will take only one sample and tell UART will assume that it is 0 or 1 bit, or it will what is its strategy behind it?
Actually, along with the transmission data, transmitter sends a parity bit, so which generally calculates an even parity or
Okay,
odd bit.
I'm not asking in terms of parity bit. I'm asking like if UART receiver UART recognize that this bit is 0 or 1, so it will take only one sample or it will take multiple sample. How it will after taking only one sample that it is high or 0 or 1, and it will get the confirmation that this will be 0 or 1, or it will have some other uh, theory behind it or other.
So that depends on our specifications. So if we specify that the signal has to be low for 2 cycle or 3 cycle, then you have to consider that start bit has happened. Similarly for stop bit also. So.
Okay. So how much payload we can send in UART maximum?
8-bit data at a time.
Okay. So before along with that, we will first send a header command. Do you know what the header command? Header command and arg bytes. You know about the how it is going to store in memory, like how it is aligned with the memory and. Okay. Come to the Verilog. Can you write a program for shift register?
Yes.
Okay, 4-bit shift register in Verilog.
Okay. So let's share my screen.
No. You take a pen and paper and write on paper, and I will give my number in chat box, and you can send me. Okay. Hello, Sizu.
Hello, sir.
Yes, Sizu. I think you are in last week in interview. Okay. I remember it. Okay. So have you completed something extra or?
Extra means
what you have studied in last 15 days after that?
Last 15 days I go with the system Verilog revision, all those Verilog system Verilog, and I touch with the UVMs.
Okay, you touch with the UVM also. Okay, so can you tell me about like which type of global signaling system Verilog we have?
Global signaling system Verilog.
We have 3 types of signals in system Verilog. So I want to know about the global signal which we have used in system before.
I don't get a global signal.
Actually, we have three types of signal in system Verilog, okay, which are going to apply in duty. Okay, so one type of signal is a global signal, then data signal, then control signal. Okay, global signal like clock and receipt signal. Okay,
Mm-hmm.
and data signal like write data, read data, and control signal write enable, read enable, write
Mm-hmm. Okay.
data, write address.
Okay.
Okay, okay. So other than that, can you explain me like I have one question. Take time scale 1 nanosecond oblique 1 picosecond.
Hmm.
Okay, write this and explain me what it define. Like, what is the meaning of that statement?
So 1 nanosecond is defined as the unit that we specified in the code. If we define 1 nanosecond divided by 1 picosecond, the precision is given in 1 picosecond. And if we declare the unit in 1 nanosecond, if we put a delay of #5, it will take us 5 nanosecond. If the delay you put in between 5.1 like that, the precision will the round value will be nearest picosecond value, 1 picosecond.
Okay, okay. So if in this particular example, if I have 12.0, so what it will take?
0.5. In this scale, sir, 1 nanosecond by 1 picosecond.
Yeah, in this particular.
0.5. 1 pico 10 raised to 12.05. 12 nanosecond, 0.5 picoseconds. Avoid 8.4.
It will ignore some least bit. I want to know which least bit it will ignore and what is the
Yeah.
exact value it will assume. Recognize
12.05. I think it ignore 846.
how.
Actually, picosecond value. I want to check it, sir.
Yeah.
I think same circle.
What is your answer? Like if we if we run this code in any code, we will mention like that. Okay, if we providing like a 12.05846, then what it will take?
Actually, if 1 nanosecond divided by 1 nanosecond, it will take us 12.
one nanosecond divided by 1 picosecond.
1 picosecond, then it will take 0.5 as the last 3 digit. It will ignore, I think. Pico is 12 raised.
Tell me answer. I want to know the answer. Which answer you are giving me? 12 point
0.5.
05. So please go through that concept. Okay. Actually, the answer is 12.0589. Okay. Okay. So can you write a code or generate a clock of 16 megahertz?
16 megahertz.
Yeah. I want to generate a clock of 16 megahertz. So how can we generate this clock? Write a code for that.
Okay.
Okay. Hello Priyanka, did you get the answer or are you?
No, sir. I don't remember code I tried to write.
Okay, if you don't know something, so don't waste the time of interviewer and please don't do any interview. Okay, if you don't know anything, just say that sir, I haven't gone through that, and I will cover later this topic and say something like that. And in which topic you are comfortable, just jump to that topic. Okay. So can you tell me how can we generate the F by 3 clock?
Actually, I'm not prepared for very long. Today, I just prepared for DFT.
Okay, so tell me, okay. Do you know about the scan insertion?
Yes, sir. Scan
What is
insertion technique. Yeah. Scan insertion technique is a DFT technique that we are using. Is the
Actually,
internal.
your voice is not all clear. If you, yeah, just put the mic close to your mouth and speak.
Yeah, yes, sir.
Okay.
First, scan insertion technique is a DFT technique that we are using with the internal circuit of the chip. So for that scan insertion, we are using a must-be scan cell in which we are using a D flip-flop. Master chip D flip-flop is the must attached to it, so that we call it as a scan cell. Scan chain insertion, what we are doing is we are taking a series of scan flops that we have to stitch them, and then we have to send the test pattern to check the. We have to send the test pattern so that we can test the circuit. I have to explain working also, sir.
Yeah. So,
Sir, working.
what?
Yes, sir. I'm telling you. Sir, in that scan insertion, there are 3 steps like load or shift mode, capture mode, and measure the output like that. So first is load. First, we have to load the test pattern in that. So all the test pattern whatever we are saying that actually load in that flip flop. After that, we have to shift it. Then we have to pulse the capture clock. So there we are sending the primary input to that scan chain. So it will replace the test pattern whatever we are sending. And after that, we have to unload it so that we can work with the normal operation. So like that, we have to do the scan insertion. So we can check whether there is any error in a particular node or any part of the circuit. So like that, we are using the scan insertion.
Okay. So, do you know about the primary input and primary output? Actually, why we are we have flip flop, na? So why we add mux? Do you know the reason behind it? Why we are using mux? We have flip flop, so why we are making a scan flip flop?
First, with normal flip flop, we can't test the circuit. Suppose if there is any issue with any one of the nodes, we can't test it properly. So to make the input controllable and observable, that's why we are using we are including mux. So we can have the two options of.
Okay. I got it. So can you draw that particular circuit diagrams? How this has primary input and primary output. This is from this input it is controllable, and from this output it is observable. Okay, so draw that diagram. I want to ask question from that particular.
Scan insertion diagram, right?
Yeah, scan insertion diagram. Actually, draw the diagram of a scan flip flop, like how we make the scan flip flop. Okay. So Swagat, have you got the answer?
Yes.
Okay, so do one thing. I am writing my number in chat box. Just take a pic and send to me. Okay.
So I want to explain, or it's 2 lines code, sir. I can explain.
Okay, explain.
Sir, in 60 megahertz, that time period will be equal to 60.
How many you take? 16 or 60?
60.
60. Okay. I have asked for the 16. Okay, explain.
Okay, no issue. Sorry, we take the time period. I get 16.666 digits, so I round off with 16.6.
Actually, just do for 16 megahertz. I want to see that particular concept.
Okay.
16 megahertz. Take time and do it. Yeah.
Sir, for 16, the time period will be 62.5 nanosecond.
Yeah.
Okay. So with the 50% of duty cycle, I declare a bit of clock, and I toggled the clock using in always hash half of the time. That is 31.25. I toggle the
Okay.
clock. Clock is equal to negation of clock.
Okay. Okay. So what time scale you have choose for that? Tick time scale.
Time scale 1 nanosecond, 1 nanosecond. I always use with that, sir. So
Okay, 1 nanosecond by 1 nanosecond. So how can it will recognize 31.25 or not? Just tell me that.
yeah, it will. I'll take if I take 1 nanosecond by 1 second, it will take 31. So if I
It
ignore
will.
25.
Okay, ignore 25. So how can we achieve that clock cycle like 31, 16 megahertz?
Yeah, the precision will be want to make arrange with that.
So it will generate the right clock or not? How can it will
For
generate
this
the right?
times
record?
for this time scale, I think it's not
So so
generating.
so so can you modify the time scale for that?
I will try, sir, but actually I did not work with that, so it will make time, I think.
Okay, just make a 1 nanosecond by 1 picosecond. Maybe it will work
One,
for that.
okay, 1 nanosecond divided by 1 second. Yeah, we can get, sir. Actually, the precision, if as soon as degrees as possible, then we can get simply,
Okay,
right?
okay. Actually, if you are not comfortable with precision, just ping me. I will send you one page of
Yeah,
notes. So you
actually, I always work with this 1 nanosecond. So
actually
that's
actually
why I'm not.
actually actually what you do it not what it is required in the industry. It's important. Okay,
Hmm.
so uh, just do one thing.
Hmm.
Understand what it will define and how it is working. Okay,
Hmm.
it will be beneficial for you. Yeah, Swagat, have you sent it?
Yes, sir. No,
Okay, okay, that's right.
Sir, I draw the circuit.
Okay, just send me. I have written my number in chat box. Just send me. Okay, okay. So, can you explain this, Swagat?
yes, sir.
Okay, okay.
So actually, I'm using two inputs, clock and reset, and output is Q. So whenever reset occurs, Q gets resetted to 0. Then after that, when reset removes, Q I am putting it as a so MSB bit I am appending as a 0 and shifting the MSB to previous LSB bit, means 3 down to 1 bit I am shifting at each positive edge of the clock by a concatenation operator.
Okay, okay. Let me continue. Concatenate operator you have used. Okay, okay. You have make a shift. You just do shifting. I want to ask the shift for the shift register.
Q will act as a shift register.
Actually, it will hold just give me a 4-bit number. Okay, so I want for the shift register. Register, you understand the register? We have 4 register. Okay, then 1 bit shift assigned to another register.
Same thing will happen in this course.
Yeah, yeah, yeah. Actually, from there I can ask some questions. So if you can write. Okay, no issue. I want to ask something else. Do you know about the delay in Verilog?
Yes, sir. There are two types of delay. In test bench, we are using inter-assignment delay and intra-assignment delay.
Okay, okay. So which is inter-assignment delay and which is intra-assignment delay? I have given two logic, okay, in chat box. So just tell me like what they are saying, like how they are assigning the value of A and C. Okay,
Okay.
okay. So Priyanka,
Yes, sir.
yeah, you have sent me that particular thing. So So, actually, I want to know if in circuit we already have flip flop. Okay, so if we check that we have flip flop and it's some function, some like some module is working as a flip flop. So in that time we need to make them scan flip flop or not.
So to test the circuit, we are making normal flip-flop to scannable flip-flop so that we can test the circuit and to make that.
If inside the circuit is some they work as a scan flip flop, so we need to again make again attach a scan flip flop or not, attach the mux or
We
not.
don't have to attach. Actually, we already insert that. It's a whole circuit of scan insertion is a whole circuit which we already insert with the chip so that we can test the circuit. This is the DFT testing circuit, so we already insert it. Just we have to send the test pattern to test the circuit.
Okay. Do you know about the ATPG?
Yes, sir.
Okay. So first we do DC compilation, or then we do DFT insertion, scan chain, then DFT insertion, then ATPG. You know this step?
What, sir? What are the steps? Right?
Actually, first we have a logic, okay, and a very low code. Then we will replace the gates of that very low code with the standard library, okay. So after that we will do the DFT insertion, where we will replace those means make the flip flop with change the flip flop with the scan flip flop, means replace the normal flip flop with the scan flip flop so that it can observable and controllable. And after
Yes.
that we will do the ATPG, automatic test pattern generation.
Yes.
So where we will get the test vector, load vector and unload vector. Okay. So can you explain each step, like how it is working, how we will do the DFT?
So from starting, I will tell whatever I had done in project, same process actually.
Okay.
Okay, sir. First, we are having like whatever I have done in my project. I am having that architectural specification. So based on that, I will write the RTL code. I will compile it and simulate it by using the model sim. After that, I will synthesize it by using the Cortex Prime. So my code is ready. Now I have a top V is there. So
I want to know only DFT perspective, not.
Okay, sir. For DFT, suppose I am having the top V, that RTL file I am having. So whatever I had done is I add the first boundary scan insertion I have done. So in that boundary scan means we have to add the tab controller pins and cancel. Boundaries cancel we have to insert inside that very log code. So after adding that only,
Okay.
we will get a modified RTL and then
you have a TC, like tab control bit, which is initially 0. When we set, then it will start the scan. Okay, so scan flip flop are arranged in which, like they are parallel or they are sequential, how they are arranged, how
sequentially they are connected. We are teaching.
Okay, they are sequentially connected. So how can you do scan insertion and sequentially? Like if I have to check a particular scan flip flop, so how you can do that?
Sir, I am having a modified RTL. I am having actually after modifying I have to synthesize that RTL code. After that only I will have the do file of that scan chain insertion do file I am having. So that in that do file I will insert that file also, which is synthesized netlist I have to add there. I can't directly add the RTL, but I need a synthesized netlist file that I will add in that, and after that I can do the scan insertion. So then we will get the result.
Okay,
Means the ATPG files we will get after that scan insertion with the do file of that scan cell. ATPG files also will generate.
ATPG file I think we get after the DFT insertion. Yeah, scan insertion.
Yes, after scan insertion only we will get that ATPG file.
Okay. So we will get the ATPG file, and after that, what is the process for testing?
So after that, ATPG file we just get like atpg.do file, ATPG test procedure file, like that files are generated along with that. So after that we have to do the ATPG process, means test pattern we have to send. There we have to tell them that what should be the test pattern and all. And after ATPG we will get a pattern.ascii file, which will tell how much is the pattern, how many patterns are generated like that. That we got after ATPG process.
Okay. So have you done any generate that ATPG file for any circuit?
Sir, I have done project on RISC processor on TFT.
So you have generated ATPG file for that?
Yes, sir. I got. Even I compared. After that ATPG, I used that EDT also. So I compared both the file patterns. ATPG having more number of pattern generation, but in EDT having less number. So like that I can compare how EDT is more useful.
Okay. So after that what is happening, like how we check test those pattern in the like in a automatic test equipment machine.
Sir, with that test equipment machine I didn't use, sir. By this
Actually nobody can use you, which is very costly. Even $1 billion machines nobody can afford it, only industry can afford it. Okay.
Yeah.
I want to just know theory behind it. Okay, no issue. Actually, what happened after that, they will compress the test pattern and send to the AT machine, and along with it will decompress that pattern, and then they will apply those pattern, and they will generate the response, and it will compare with the golden response. Okay, and then after we will get to know that where is the default and which flip flow.
That means we are getting the compacted response, and we can check where is there is a fault or not. Like that, we can check.
Yeah. Actually, the testing cost is very costly, and around that $3 to $4 per second. So which is very costly, and that's why we are trying to compress, use some compression algorithm for that, Huffman coding, dictionary encoding, another long run coding scheme, and after that compression we will apply those patterns. Okay, and also the bandwidth of that ATE machine is very low. Okay, so we and also the memory assigned to the ATP machine is very costly. So that's why we are actually, when you are going with to the core based design, so the number of test pattern is increase exponentially. Okay, if we increase the gate size in hundreds, so then with the testing, like test pattern is increased in megabits, millions of GB. So that's
we
why
are using that response analyzer to reduce it.
No, response analyzer is something different. We are compress that test, try to compress, and then we will apply. Okay. So along other than that, what you have covered?
Subnet boundary scan insertion, EDT.
Do you have any basic knowledge of Verilog, system Verilog, and digital?
Yes, sir. I have just not revised. I know digital Verilog.
Can you write down difference between 3 to 5 points in difference between the Moore machine and Mealy machine? Okay. Swagat. Okay. First will be will get assignments and next question. 5 hours. Okay, it's okay. Okay. So Swagat, can you tell me what double equal to and triple equal to, what they are?
Double equal is the logical equality operator.
And what is triple equal?
Triple equality is the means we are checking a bit.
Actually कि हम कहाँ फंसते हैं, हम बेसिक में ही अटके हैं. तो बताओ what is the double equal to and what is the triple equal to?
Triple equal to we are generally used to compare individual bits of a bit stream.
Okay. So where we can use the four state, and where we can use like which type of bits it compare, double equal to and triple equal to.
Sorry, sir, can you please repeat?
Actually, in double equal to, in one of the operator we can only compare in one we can also compare the jet. Like
Okay, triple equal to.
in double equal to we can compare the jet.
Yes.
There we can't compare that.
Double equal to.
Okay. If we have a 2-bit 101 x and 101 0. So if I compare that bit in double equal to, then what is the output? And if I compare this in triple equal to, then what is the output? Hello, Susan.
Hello, sir.
Yeah, I have assigned give you some question or not parted?
No, sir, no questions.
No question. Okay. So, can I ask question from system viewer?
Yeah, sure, sir.
Okay. So how can we do the randomization in system viewer?
Sorry, sir, I can hear you.
Randomization.
Randomization.
Yeah, randomization.
So for a high level of testing, we give stimulus with the randomization perspectives. We cannot give stimulus with linearly, so we go with the randomization.
Okay. So how can we give the randomization to the like what is the syntax for that and how can
we can randomize transaction level also and bit level also. If you like, if we declare a class with the keyword of rand in some variable, then we declare the transaction, all the bit that were declared in the class with the keyword of rand, all the bit will be go to the randomization as per the size also we declare.
Okay. So in randomize rand C keyword, by using the rand keyword, we will get some repetition of the values. Okay. If I didn't want to repetition of those values, then what keyword we have to use instead of rand?
Cyclic we can use a rand C keyword. If you put a rand C keyword, then after one cycle only we repeat those values.
Okay. If I want to get the confirmation that randomization is successful, then what is your strategy?
I think assert can be used, sir. Assert it's a randomization. We can get the confirmation.
Assert. Okay. So
other than we can also just get the packet display. If we get those packet some values, we can just compare and like that also.
Okay. Okay. We will use the assert keyword for check the randomization is successful or not. Okay. Actually, in system Verilog, basically we need to. Actually, you can tell me about the pre and post randomization method. What they are.
The pre and post randomization method. If you call the randomization, the pre and post methods are automatically called. I think it came from the callback method. It's an inbuilt mechanism. In post randomization, it function. If you call the post randomization function, we can have the randomized value of get the value after randomization that we can get inside the class only. Inside the class also we can get the value.
Okay, so
Pre-randomization is before what value we
can you give me an example of
Yeah.
pre and post randomization?
Yeah.
Just take a pen and paper, right?
For course, sir?
For pre and post randomization, both.
Okay. Can I for paper and notepad?
Just write only that part, not whole code.
Oh, okay.
Don't go. Okay. You don't. Okay. So, Priyanka, you said Mealy machine is asynchronous and Moore machine is synchronous. Okay. And it requires less number of states and requires more number of states. Now, do you know the if I have n number of states in Mealy machine and hello?
Yes, sir.
And if I have n number of state and x bit as input in Mealy machine, then can you tell me what are the state number of state in Mealy machine? How many states are there in Mealy machine?
X bit means x plus 1 number of states will come.
Actually, just
Whatever number of states are there, one more extra number of states generally are there in Moore.
From where did you read it? Like from
Not read, sir, but it happens now. Like they give the code 1010. So generally five states we are writing for Moore, and for Mealy correct that state only 4 states because 4-bit number is there.
Are you sure?
Yes, sir. I mean we draw like that only. No?
Actually, this is 100% wrong. Okay. Okay, this is only for the specific case in sequence detector. Okay, not for the whole FSM. Okay. Okay, just go to that concept. If you didn't get it, then ping me. I will send you the review of that chapter. Okay, so it is difficult to design. It is.
Sir, I not with the go over the syntax, just logic only. Sir.
Okay, let me see. So, just wait. So, can you, if I think I will give you one question, like to detect a sequence. So, can you tell me the answer for that? Yeah, draw the state diagram for sequence detector.
For me,
No, for Priyanka.
Yes, sir.
Okay. Draw the state diagram overlap for that.
So Moore or Mealy.
Anyone you can get. Okay. First Swagat, what you have written? Okay. The first one is incorrect. And for second one it is correct. Okay. Okay, you are right. So Swagat, can you tell me the difference between deep copy and shallow copy?
Yes, sir.
Yes,
So, sorry.
A deep copy and shallow copy.
Yes, sir. So, in shallow copy, we are simply copying all the properties of a main object to the copied object along with the handle of a subclass object. But in deep copy, entire things present inside a class like subclass object as well as all the properties, we are copying entirely to the new object.
Okay. Sizu, just tell me about the distribution of randomization. How can we distribute the constraint?
constraint distribute. I think it's weight distributions.
Yeah,
Weighted and weighted and non-weighted are there. District keyword is I'm sorry. District keyword is useful for weighting. It's not
Can
not
you
equal to
can you give me an example for that?
yeah. How can I just want to write?
Yeah, just give me an example. Just write it and send me.
Just if you randomize to
Just
a
write
group.
write and payment. Actually, hello, Swagat.
Yes.
Uh, so, what you have told me? Just can you repeat it?
Shallow copy means in a class, if some properties as well as a subclass object is there, then if we perform a shallow copy of that class, then we are going to copy all the properties of that class along with handle of the subclass object to a new class, new object. But in deep copy, all the properties along with subclass objects gets copied to the new object.
Okay. Along with we have one copy method, one more copy method. Do you know about that method?
Uh, yes, the customized copy method.
Yeah, customized copy method, custom copy method.
Yes.
So, can you tell me about that?
So customizer means as per our requirement, if some of the properties we want to copy to another object, we can put those properties inside that copy function. And whenever we call the copy function, that required number of properties are going to get copied to the new object.
Okay. So, we have three methods for custom copy method, then shallow and deep copy method. Okay.
Yes.
So, if we have a data member and class in object, okay. So if we use deep copy method, then what things are copied in copied class?
Everything, sir. Properties along with subclass object.
Okay. So if we have shallow copy, then what happens?
So only properties of that main of means original object, original class will get copied along with handle of the subclass object will get copied.
Okay. So if I will try to change the value of our data member in deep copy, so what these changes are reflect in original copy or not? Means
No,
object class or not?
no,
No. Or if I will do, why it is not?
because in deep copy, complete new object you are copying in that new. Sorry.
Okay. So in shallow copy we will get the access of handler, so common handler.
Yes.
So we which make the changes in shallow copy, then these changes are reflected in the
Original
object
object.
original copy. So it's okay, like you guys are okay with your concepts. Just do add some project also. Those are industry level projects. And can you tell me about like inter-process communication? What are mechanism we have for the inter-process communication in system level?
Me, sir.
What are mechanism we have for the inter-process communication?
Mailbox we have and event-based interprocess communication we have.
We also have a semaphore. What is the semaphore?
Sorry.
What is the semaphore?
Semaphore is also there. Event-based semaphore mailbox three types.
What is semaphore?
So semaphore is generally used to access data from top class object to internal object, internal process.
Okay. Semaphore. This is used to access the certain resources in a system very locust range.
Yes.
For semaphore, we have the gate and put method. For event, what we have?
Sorry.
For event, what we have for event?
Event we have timing based event control as well as level sensitive event control. So at the rate and wait.
At the rate and wait. And what is the mailbox?
Mailbox is generally used to establish communication between two different classes. Like if you want to send some data from one class to another, mailbox is generally used.
Okay. For event we have three things. Okay. One is age sensitive, level sensitive, and weight. Age sensitive, event sensitive, and weight level sensitive.
Yes.
Okay. Okay. Actually, I want to see your coding skills. Now, I think time is over for now. And Priyanka, you send me the answer. I got it. I think it's okay. Then Sizu, you sent for what are you asking? Okay, got it.
Yes, constraints. I put the weight of one. It's a 2-bit data. Then put the constraints of 1 is equal to 5.
Okay. Constant. So do one thing. Prepare your resume with in LaTeX format. Everyone. Okay.
Yeah, I also do with that lattice form.
Or LaTeX format. Also add the keywords. Okay. So have you anyone of have done project on disk 5?
Yes, sir. DFT process. Project on this type of.
Okay. And you, Swagat and Sizu?
No, sir. The projects on no, sir. I like basic projects only. Like I signals FIFO and FIFO vending machine kind of projects only.
Do one project on risk process. Talk to Rajat and say that I want to complete my project on risk factors. It is very important. And Swagat also, if you want to move your career to that verification domain, then do project on risk factors. Okay.
And what is LaTeX processor?
LaTeX format. People say LaTeX format. Actually, these are format which AI will detect easily. Okay. Whenever you apply for your resume in any company, they will use some machine learning or artificial intelligence to sort shorten for the resume. Okay. So that format is very useful for that. Okay. Other than that, Priyanka, can you explain what is RISC-V, like which state are you using and how many states are there? Yeah.
So this file is the processor. It is having some instructions like register, immediate, store, load, like that. Some instructions are there. I have not revised, but there are some instructions, and according to instructions only, we have to work there. I need to revise first.
Okay. Actually, I have so many questions on this processor. Maybe when you return back, just complete your whole thing. Then we will talk in this approx 1 hour.
Actually, sir, I am planning to prepare for verification because DFT I am trying, but there is no job coming for me. So I am thinking to study SV and UVM now.
Okay. So complete your RISC-V processor.
Okay.
Actually, I also work on this 5 and ARM7 processor. Also, I work on the data compression. I work on very log system VLSI. Also, I know STA. Also, I know some industry level UART protocol, SPI, I2C, AMBA, PCI, SATA. Okay. So, in RISC-V processor, there are R type, I type, load, store, branch type, jump type instruction, and after that these instruction. I have made my own instruction for the RISC-V process. If you come with after completion, then we will discuss about that. Okay.
Yes, sir. I will revise that part.
Okay, revise it. I'll also complete the theory behind it. And have you guys know computer architecture? Swagat, Sizu, and you.
Not that much. Good, sir.
You, Sizu?
Sir, in basic subject is prepared. Means digital, Verilog, SC,
Verilog.
UVM, DFT. That's it.
Best,
And
yeah.
CMOS,
Actually-
FPGA, for give some notes. So we prepare that.
Actually, in industry, they will basically work on all SoC, ASIC, and FPGA. Okay, so they want you to know about the computer architecture. Okay, everything about the computer architecture. Computer architecture is very important. They don't have the question from the basic digital, and they will ask a question from the computer architecture. Okay. So complete your computer architecture from somewhere. Maybe Bharatacharya, I think, is best. Okay, and also you can ask Rajat to provide the lecture of computer architecture. Okay. So complete your computer architecture, and if you have any question, then ask. Anyone have any question for me?
Yes. Hello. Yes, sir.
Ask. Yeah. Continue.
Sir, so those driver creation, do you need to do from the scratch while interfacing two components like microcontroller with FPGA? So, do you need to create those drivers from the scratch, or is it ready?
Actually, you asked the driver for system level or UVM or driver for
Normal
microcontroller.
like master and slave creation, those things.
No. I want to ask you want to ask a driver for very low system very low or controller?
Very low. Sir.
In system very low, na?
System.
Okay. So you have to write the code for driver. Actually, in industry, what happens? No? They will have a platform like VS Code. On the top of that, they will add something. Okay. So industry they will provide some base code, and on the top of that you have to do some modification according to the specific requirement, and then you can do it. And for a small project, like if you want to make the combination ladder, then you have to write it from the scratch. I thought you asked for the driver, which is the driver for the operating system, operating system or microcontroller. And also do some protocols also for like I2C, I3C, SPI, and UART. These protocol is enough. And Amba also if you can do it. Okay. And you and Priyanka, I think, have some experience of the industry, no?
No, sir. Previously, I was working, but in insurance field, sir. So you can consider me fresher for this VLSI field. I completed MTech, but I have not entered the VLSI. Now I want to enter.
Okay, no issue. If you are facing any issue in system variable, first go with the basic, complete your C programming, then OOPS concept and some portion of C++. Then only you are able to understand the UVM concept and system variable. In initial, yeah.
If you're not with the actually the UVM concept is clear, but if you're not good with the syntax, it's okay, na? We can get the syntax from anywhere.
Syntax. Okay, syntax. No? So you have to make a short notes like and frequently you have to revise for that. Huh? So also you don't know about good with the OOPS concept. So then you are not able to understand what is happening. Why we are using OOPS in system vehicle? First question. Can anyone tell me like why we are using OOPS in system vehicle?
Because all the work happens inside UVM is completely with the 4 pillar of system value, abstraction, polymorphism, everything has happened.
No. Why you know object-oriented programming is they will assign the memory only the time when they require. After
Yeah.
that it will, okay, so it will doesn't require so much space. Okay, for the verification, if we use any other language, so it will require a huge memory.
Yeah. Correct.
Okay, got it, no? So it will require huge memory. So to save the memory, we will move to the object oriented programming.
Object everything.
That's why we are using object oriented programming. After that, they will move to system UVM. Just go start with the basic and complete your.
Sir, recently they are using Coco TV, like Python based.
Yeah, Python. In my company, they are using Python.
So which is better, SBUV or Coco TV?
Actually, I haven't found any lecture on any social media platform or any Udemy and somewhere for the verification yeah, based on Python. Maybe after some time it will come. But now you should cover the system log assertion and coverage and basics of UVM. It is okay for you if you are going to join as a person. Okay for then. Okay, I think if you anyone have any other question?
Sir, I am planning to shift from VFT to verification. That is fine now, because I'm trying from 3 months almost. And again,
If you are not, just give yourself some time. Okay, you do oops concept first.
but sir, my year is also the issue 2017 pass out. So I think maybe it's problem for DFT. Because whenever I applied, it is telling only 2 years experience are required. So for trained freshers, there is no opening.
For the active profile, they will always prefer experienced person.
Yeah. So at least to get entry in VLSI, I thought to move in verification again.
Yeah. So just try to get a verification or design. And
Yes, sir.
after that, you can do the active profile. Okay,
Yes, sir.
so if you are not getting that how to, let's say if you are getting problem in system, you let's first complete your oops concept, then you will move to do it. Because then you are able to understand what is happening.
Yes, sir.
Okay, for now it's okay. It's okay for that. We will. Can I cut the call? Clear the call?
Yeah.